Hi, myself Vaishnavi, Assistant Professor in the Department of Information Technology from SNS College of Engineering. Now let us see about the Boyce code normal form. If a table does not have any composite attribute and multivalue attribute, then these two conditions means that the table is in first normal form. The table does not have a partial dependency and it is in first normal form, then these two conditions means that the table is in second normal form. Then the table does not have any transitive dependency and it is in second normal form, then these two conditions means that the table is in third normal form. And finally, if a table is in third normal form and if left hand side of every functional dependency of the table is a candidate key or super key, then these two conditions means that the table is in Boyce code normal form or BCNF. So what does it mean that? Let us see with an example. So there are two conditions for Boyce code normal form or as follows. First, the table must be in third normal form. BCNF is sometimes referred to as extension of third normal form. The second condition is every functional dependency in the table or a relation, say x determines the y. The left hand side of or x should always be candidate key or a super key. Should be of this form. If any table satisfies these two conditions, then we can conclude that the table is in Boyce code normal form or BCNF. Let us try with the simple conditions. So using these examples, so let us understand the first condition. We need to check if the table is in third normal form. So let us consider this table as an example. In this table, no single attribute can identify complete tuple. So candidate key needs to be a combination. Using student and subject combined, we can determine the teacher. So as student and subject combined, we can get complete tuple. It is a candidate key. And following are the functional dependencies for this table. Student and subject determines teacher. And using teacher, we can determine subject. As one teacher teaches just one subject, if a table is in third normal form, then it is also in second normal form and also in first normal form. So we need to check right from first normal form. This table does not have composite attribute and also does not have multivalued attributes. So we can conclude that this table is in first normal form. For second normal form, we need to check a partial dependency. In simple terms, there should not be any functional dependency. X determines y, where y is a non-prime attribute and x is a part of a candidate key. If there is no functional dependency of this form, then the table is in second normal form. Now let us check each functional dependency of our table. First one is student and subject determines teacher. So in this, complete candidate key determines non-prime attribute. So this cannot be a partial dependency. As a complete candidate key is used to determine, let us check another functional dependency. Teacher determines subject. In this functional dependency, non-prime attribute determines part of a candidate key. In this functional dependency, there is a part of candidate key, but it is not on the right hand side. Partial dependency is when part of a candidate key is on left hand side. So this particular functional dependency is also not a partial dependency. So this table does not have any partial dependency and it is also in first normal form and therefore second normal form. We can conclude this in a second normal form. Now for the third normal form, we need to check if there is any transitive dependency present in a table. In simple terms, functional dependency is transitive if a non-prime attribute determines another non-prime attribute. So let us check if this table is functional dependencies or transitive or not. First dependency is student and subject determine teacher. So candidate key determines non-prime attribute. So this is dependency, cannot be transitive. Let us check second functional dependency. Teacher determines subject. In this functional dependency, a non-prime attribute determines part of a candidate key. That means a non-prime attribute determines prime attribute. So this functional dependency does not match the transitive dependency condition. So no functional dependency of this table is transitive. The table is in second normal form and has no transitive dependency. Therefore, we can conclude that this table is in third normal form. So we have proved that this table is in third normal form. Now we need to check second condition for Boyce code normal form. Now we need to check if that every functional dependency in the table is of from X determines Y, where X or left hand side is strictly a candidate key or a super key. Let us check if our table satisfies this condition. Student subject determines teacher. Candidate key determines a non-prime attribute in this functional dependency. LHS or left hand side is a candidate key, so there is no problem with this functional dependency. Next functional dependency we have is teacher determines subject. A non-prime attribute determines part of a candidate key. Now, this dependency is neither partial nor transitive, but LHS of this functional dependency not a candidate key or a super key. So this functional dependency breaks the second condition required for Boyce code normal form. Therefore, due to this functional dependency, this table is not in Boyce code normal form. So, what is required to transform this table in Boyce code normal form? We need to decompose the table. So, we had a relation or a table R with student, subject and teacher attributes, where teacher determines subject. Functional dependency is not allowed. So, we will decompose the table into different tables. R1 and second one will be R2. We'll have attributes from the functional dependency that is not allowed. So that functional dependency was teacher determined subject. So R2 will have teacher and subject. As its attributes were teacher is primary key. And R1 will have a student and teacher attributes where student is a primary key. Teacher is a foreign key, which is a primary key in R2. So now this relation is decomposed in two different relations and transformed it to Boyce code normal form.